All right, let's start. I got a little bit late because I answered a couple of emails regarding the hand-in of workshop 1, the peer review stuff. So the form is still open. So if you got some late reviews, like 11:59 yesterday, and haven't had a good chance to read them through yet, you still have the chance to do so and hand in your results from that. Also, you need to be logged in on the CoursePress platform using your student account for the links to work. I had some email that thought the links were closed also because of that. So one more thing, I think. Let's close that one. There we have it. So you can still submit the peer reviews. I will close the form during the afternoon today, so you have some time yet to do so. And you have the last, I will switch to English. You have the last submission deadlines the 7th of November. So you still have the chance to improve your workshop for grade 3 during the length of the course. So you don't have to update it for today. But you look through the review you got and check, okay, does this look good? Do they say anything helpful to us? And you have throughout the course to actually do updates and do fixes and do improvements to all of your workshop models. Yeah, questions regarding that procedure? Good. You have the workshop this week also, the second one. As I said before, get a development environment up and running. I recommend you doing something in console-based to not put too much effort into graphical user interface stuff, because that's not really the focus of the course. Console app in Visual Studio is fine. C#, for example, would be great. NetBeans, I don't really know. It's Java, I guess, but I guess it's web-based. So adding web-based architecture on top is a little bit, can be a little bit cumbersome. But the choice is actually up to you. So do it in some object-oriented language that you are familiar with and feel is doable. So, and also the workshop, you will probably not finish the workshop for grade 3 during the scheduled hours, but try to finish something and work in the way that we do on the lectures. Do a little bit of design, do a little bit of implementation, update your design, work feature by feature, so that you don't sit there and design the whole workshop and implement nothing, or vice versa. And please do present something towards the end. It does not need to be finished, and you can also present something where you have, okay, we did not know how to solve this. Does anyone have any ideas? So presentation is the first step for getting feedback on your workshop. And then we will do a similar peer review process where you get to review 2 other models and workshops and send feedback to them and get feedback also. All right. Yeah, we have a question. Yeah, I think for we can look at the schedule. No, no, not for the PHP. I think no, it's not posted yet. It gets posted on at the workshop. So there is nothing to prepare actually, except to understand what we have done in the lectures. All right, to continue where we left off, we started our blackjack game. That will be the case that we will follow throughout the rest of the course mostly. And we created two classes, the card class and the deck class. I think we were kind of finished, but we had not implemented this shuffle operation yet. So to save some time, I will just paste some code into it and hope that it works. So something like that. So the process for shuffling is just pick a random card from the linked list of cards, remove it, and add it at the top. So a lot of random cards are picked and just added at the top, and this should be a good shuffling of the deck. So we will try and compile that and get a I think we had was it program or what was it up here? Run blackjack. So this was before we had a sorted list of our cards, and we will now compile. Add card was not, it was just add. There was a lot of cards, I think. Yeah, 9 of diamonds twice. So something wonky is, seems to be happening here. Okay, it's probably because we print here in the model. And this is of course bad because it looked like we had a bug right now. So this should be removed, and let's put it in the program instead, for now at least, just to know that we get something. So, okay, this brings up actually another interesting problem, because we need to be able to iterate over the cards in the deck to get this debug printout. How should we do that? Any ideas? We need to be able to get the cards that are inside of this list. How should we do that? list method is proposed here in the chat. I don't... What do you mean by a list method? Something like this, maybe. Oops. So this should probably do the trick. We added a get cards operation that just returns the list out, and we can iterate over this list and print the cards. So let's try that. All right. Yeah, seems to work. We just get the first deck, and it seems to be kind of random. Random enough. So, all right. Was this choice a good choice? That's kind of a leading question, I guess. Adding a get cards operation like that. We get no from Svante. Yeah, and it's not read only. And that is the thing that you should be very, very concerned about. This method now exposes the internals of the deck class. So we have broken encapsulation. And encapsulation was one of the foundations for using object-oriented principles. We can encapsulate stuff. So by returning the list, people that use the deck class can get the list of cards and start manipulating that list. There is nothing stopping us right now from adding cards right into the deck or removing cards from the deck as we see fit. So adding a method like this is not a good idea. And it exposes also the way that we stored the cards in. So developers will start using this operations that are unique for this storage class list and become dependent on it. And if we would like to change it to something else, and we change it here in the deck class and think, oh, this is encapsulated in this find class. But it's not. It has probably spread out all through the application. Yeah, you could make it into an array and then return the array. Yeah, there are some ways to deal with this, of course. And the standard way in most languages is that there is some kind of read-only iterable construction that you can use that just allows you to iterate through the cards and not do anything with this collection that you iterate through. So, and in Java it is something like this. So, Do you understand the possibilities that you kind of like expose your design to when you do kind of like this? Oh, yes, let's just return the array of stuff, or let's just return the list of stuff. Many small errors like this kind of like add up, and they destroy your application and your design. So think about what you do when you add something like this, and think about the consequences it has. And think about what is it that we actually want to allow. What is it that we want to do? Okay, we want to iterate over the cards. We don't want to pick a card. We don't want to put cards into the list. We don't want to do anything like that. We just want to iterate through the cards. And the operation should be about that and not expose much more. Yeah, I think iterable is an interface to all kinds of collections in Java. There is some counterpart in C# also. And in C++, you have a wonderful construction that has not been copied to many other languages I know of, and it's the const construction, where you can just say an object or an operation is const. That is, it does not change the state of the object, and you're not allowed to call stuff that changes state on objects. And this is kind of awesome, I think. Can't this just be cast back to a list? I don't think so, because you can't do upcasting probably. But there could be ways to work around this, but it will require probably some work, and it will be harder for a developer to do that. And one of the points of designing is to make good choices obvious for developers. The developer should only have one option. I want to do this. There should be one way to do that. I want to get the first card out of the deck. Okay, we add a method for that in the deck class. We don't return the list out because I don't know what to do with the list. Or we add both of them, so a developer does not know, okay, should I use this get card, get first card operation, or should I get the list and pick the card myself, or what should I do? So we want to make it simple for a developer or a programmer that gets a task to solve inside our design. So let's just try to compile that and run it and see if it works. Oh. Get cards. Wasn't it named that like that? Maybe we need to recompile that one also. Yeah, and we have kind of like the same result here. So we don't really have much of an architecture right now, so because we just have two model classes, and we have some printouts here. So let's move this to the proper architecture instead, and we will do that by just adding a view to get the responsibility to print the decks for now. this code from here instead. Move it in here. Didn't I? Oh. So something like that I think should do it. And we create this view, blackjack view. So, good. Same result, and we have moved the actual presenting of the deck to the view class, and maybe we should just get a controller class up and running here also, so that we kind of like have the architecture up and running. Yeah, I get a question here in the chat about grasp. Is controller and grasp the same thing as a controller in Model View Controller? More or less, at least. The idea is the same, but we will be talking about the grasp patterns in a short while here, so be patient. Let's call it C. So I think we are I'm just about ready to compile this. Cannot find symbol. This gets me all the time with Java. Isn't it? Console. Oh. No, this was right. I was in the wrong. So, all right. It was not named console. Play game. Play game. And we have the same result. So, all right, we have the actual architecture up and running. We have touched all the components. We have touched stuff in the model. We have added a simple controller, and we have added a simple view. So the architecture is actually kind of like up and running. So we know that the fundamentals work here. So let's go back to some theoretical stuff then. And what he proposed in the book to use as a design method is what he calls what is called responsibility-driven design. And you have probably heard me talk a little bit and say the word responsibility. Oh, which class should have this responsibility? Who should do this? And so on. So the general idea is to think about responsibilities, and that objects have responsibilities for knowing, stuff, or doing stuff. So when we encounter in our requirements, okay, card, we should have a color and a value for a card. Who should be responsible for knowing that? Well, the object of the card type should be responsible for knowing its own color and value, of course. So in some cases this is really kind of like easy and natural. In other cases it is a little bit more complex. So, but we add attributes to classes to capture this knowing responsibility. And maybe a little bit trickier is when you get some behavior that you need. Who should be doing this? Who should be responsible for shuffling the deck? Ooh, should we select the dealer, for example, could be one candidate for that. Because, well, in real life, the dealer is the one who shuffles the deck. So that could be a natural design choice. Also, the deck itself could shuffle. In reality, that would mean a self-shuffling deck. Maybe a little bit wonky, but maybe natural in some other ways. So we add operations for this. And in the book, he has constructed a number of patterns, of course, for thinking about how to find good ways of assigning responsibility. And these are the general responsibility assignment software patterns, GRASP. I don't know, the acronym is kinda cool, but it's also a little bit out there maybe, just to get a good acronym. So it seems as if the smartboard does not want to play really that nicely with me, so I will have the writing down to bare minimum here, I think. So, for example, when we thought about this problem of shuffling the deck, we could have selected to introduce the dealer class to do the shuffling. We could also have added it to the already existing class deck that we already had, and for some reason we choose to have it in the deck class. And one of the principles he is talking about is the information expert. That is maybe the first pattern that is introduced. I also think that you have it in your first, in the cover of your book, if you have the book. And what the information expert pattern says is the class that has access to the information needed to perform the task should be assigned the responsibility to perform the task. In this case, we need to know all the cards in the deck, and who knows that, who has that information? The deck has that information. So the information expert then tells us to add this operation of shuffling the cards to the one that has the information needed, in this case the cards, and do this shuffling. If we would have added this to the dealer class, it would have to get the cards from the deck and put the cards back into the deck. And just by thinking about that and looking at the code, if you have coded it, you would see there it would be a lot of communication. I would call the deck, get the card, put it back in, call the deck, get the card, put it back in, and so on and so forth. So also the code would kind of like speak to you and tell you to, okay, this should probably be moved to the deck, because all you do here is call the deck all the time. So that is the information expert pattern. And it's a general principle of adding responsibilities to your classes. And this is actually one pattern that you should always have in mind. And there is at least I have a tendency to make things a little bit more complicated than they need to be, and always think about this, who has the information needed, and you will be in a good way. Yeah?
If the deck shuffle itself, who has the authority to tell the deck to shuffle itself?
Yeah.
It should only be the dealer who can tell the deck to shuffle itself.
Yeah, right now I think the deck is automatically shuffled when it is created. I think the shuffle method is
Just like for example,
yeah,
later on in the program when we actually have a dealer.
yeah. I would probably add that responsibility to the dealers to call the shuffle method.
Do that from, can you tell the model that only this type of object will tell you performing this task?
Not in a really easy way, because all that has access to the deck will be able to call that operation. And that is also a problematic area. For example, in this case, in our case, yeah, absolutely. So you should strive to hide this kind of information. In our case, we here in our console view right now have access to the deck. So given this, someone could start doing funky things to the deck right now from the view. I don't think we have really that much operations that you can do. You can get the cards. That's about it right now. But you should of course always be wary about this. Having really big classes with lots of operations and giving them to someone makes their lives a little bit more complicated. They don't really know what to do. And the first step is of course to have such a small interface as possible for your classes. Not add thousands of operations that kind of like do the same thing. Just like if we would have had a get card operation and a get cards that return the list. You would kind of like have two ways to do the same thing, two possibilities. So that's the first step to limit. But it would have been great here to have some kind of read-only deck that is sent to the view. In C++, that can be easily done. I don't know if it's possible in Java, but in C++ you can just add, for example here, the keyword const. So the deck would be a constant object. You're not allowed to call any operations that change the deck. But this is a construction language feature that I have not seen in very many languages. So the way to do this in other languages would probably be to construct some kind of read-only interface, and that is what you get. But it is a good question, and it is problematic because you kind of like want to make the life for the developer as easy as possible and not expose too much stuff in your classes. And the primary way to do that is to do stuff private and protected for as long as possible. But sometimes stuff needs to happen in objects also, so there is a fine balance there. So this was the information expert. Information expert grasp pattern. It is very basic, and you should really go back to this. If you kind of like don't know what to do, think about, okay, what information is needed to perform this task? What collection of objects has that information? Who should then be doing this according to the information expert pattern? The next pattern we have actually used is creator pattern. And this is a pattern that is about creating objects. And we had the problem, okay, who should be creating all the cards? And there is kind of really wonky description that you need to read for yourselves. But it says assign class B to be responsible for creating an instance of class A if one of these is true. B contains A, B aggregates A, B has the initializing data for A, B records A, B closely uses A. In our case, we could see in our domain model that the deck contains the cards, so we have this instance of deck contains cards. Okay, that points to the deck class being responsible for creating the cards. We also have an instance of thinking about the information needed to create the cards. Since we want to have a full deck, we need to know what cards we have already created. And this is also something that the deck class knows. I know what cards I have created before, so this also points to the deck being the information expert in this case. And last and not least, we added the we have used at least a little bit of the controller pattern here. And the controller pattern is about who should handle big events in the application. Like, okay, we want to start a new game, we want to quit. In a bigger system, you probably have events for triggering different use cases. I want to add a new user. I want to add a new rock genre or whatnot. And these are called system events, important stuff that happens in the application. It is not really filling out one little text box or filling out one little drag and drop stuff or clickable. It's more if we talk about the web, it's more like, okay, this form is filled in now. The user wants to add the user that he has filled in the information for. And this should be added to a class that either encapsulates the whole system, a subsystem, or a hardware device. And this is a little bit not that applicable to our systems because we do really use case driven and very interactive systems. It is maybe more so if you have special hardware devices that you need to handle. And the other case is to assign the responsibility to a class that represents a use case scenario within which the event occurs. And that was the reason for us using this play game controller. The use case is play the game, and we have a play operation in it. So that is the first kind of like system event that occurs in our little application so far. We play the game, and currently it only displays the shuffled deck. So I think we should take a small break here. Any questions? No? Okay. I think after the break we will be constructing a sequence diagram for the code that we have done. I hope the smartboard would like to do that also, but we will see. I think maybe we have a question here in the chat. Yeah, there are more grasp patterns. 1, 2, 3, 4, 5, 6, 7, 8, 9, I think, and we have done the first 3 so far. So we will be coming to low coupling and high cohesion also. We have actually already touched them a little bit, but it has maybe not been that obvious. So let's take a 15 minutes break.